Question number 5, we want to run through our very first principle, and that is to look for a greatest common factor. Is there something that will go into 8x squared and a 24x evenly? And certainly 8 will go into 8 and 24 evenly, and also we can factor out an x out of both of them, which means we're dividing both of these terms by 8x. So factoring is division, so we divide 8x squared by 8x, we're left with an x. Minus, and then 24 divided by 8 is a 3, and x divided by x is 1 equals 0. So once we get this factor, we can take a look at what we have, and this is not the difference to perfect squares. As a matter of fact, it's a linear factor, so our factorization process is over, so now we're looking at applying our zero factor theorem. Keeping in mind that we've got 3 numbers this time that are multiplied together. One of them has to be 0. Either A is 0, B is 0, or C is 0. I'm referring to my 3 numbers as either 8 is 0, which is not, or my second number I'm multiplying together is x, could that be a 0, and my third number is x minus 3 equals 0. I've already established that I can't make an 8 a 0, but if I've used x equals 0, I've now fixed it so that my solution to the equation is 0, because if I put in a 0 for this x, then 0 times 8 times negative 3 is 0, so that's what I'm thinking about. So what I want to do is take each of these factors, x equals 0, and my other factors, x minus 3 equals 0. This one's already solved. Solve this one for x, and x is a 3. And if I plug 3 in there, I get a 0. So the 2 solutions to this equation are 0 and 3. Using zeros of the factor, or zeros of the function to help us solve a solution set for quadratics.